Hello, students. Video we are going to discuss. Let's begin. The first question that is given to us is reacting with ammonia. So what will be this reaction? This is a carboxylic acid, and a carboxylic acid is reacting with ammonia. So we get an amide. Right? The product that we'll get in the first step will be CH3CO NH2. Right. In the second step, we have conductor reduction reaction. Hydrogen in the presence of palladium. What will be this reaction? Now, hydrogen in palladium is not a strong reducing agent, so it will not be able to reduce amide. But the ketone group, this ketone group will be reduced. Okay, ketone will be reduced to secondary alcohol. So the product that we'll get will be CH3CH2CO NH2, which is given in option C. Okay, let's talk about the second question. In the second question, we have been given an ester RCO OR prime, right? And in the first step, we are reacting it with hydrazine. So what will happen? Here, a nucleophilic substitution will take place on the carbonyl group. Will form a tetrahedral intermediate and will collapse the tetrahedral intermediate and will depart this ester group. Okay. So the product that we'll get will be R CO N H NH. Okay. Now, this is a hydrazine derivative of carbonyl compound, or it can here Wolff rearrangement can take place. Okay, there is a RCONH group, and this group you can see the rearrangement that will take place will be nitrogen will donate its lone pair onto this carbon, and this R group will migrate to nitrogen, and simultaneously this NH2 group will depart from it. Okay, this is the mechanism that will take place. So the product that we get in the presence of HNO2 So what will be this role of this HNO2? This HNO2 will combine with this NH2 group, and we get an N2 plus or diazo compound, which will be a good leaving group. Okay. So instead of NH2, it will be better to write it as N2 plus. Okay. One of the byproducts will be nitrogen, N2 gas. So when this Wolff rearrangement takes place, we'll get R N H C double bond O. Okay. And double bond C double bond O. Now from here, what will take place? H plus will depart. Okay. There is a solvent present in the solution, which is water. So water will abstract this H plus ion, and we get a lone pair on nitrogen. Okay. So the product will be RNCO. double bond C, double bond O. Now, in this reaction, if we reacted with uh, ethanol, what will be the second step? Now, ethanol is a nucleophile, and yet this carbon is an electrophile. So this OH will attack on this carbon, and this bond will break and come to nitrogen. Okay, and again we get R N. Here already one lone pair was there. This lone pair had come on nitrogen in the previous step, so there is one lone pair already, and one more lone pair will come, so that nitrogen will become negative charge. C double bond O, C2H5. Okay. Now what will happen? Again, there is solvent present in the solution, C2H5OH. So it will get this. It is occurring in acidic medium. Sorry, it is occurring in aqueous medium. So we have water as a solvent. What will happen? This negative charge will abstract this hydrogen, and this oxygen will get the lone pair OH. So we get R NH C double bond O C2H5. Okay. Again, this will depart, and we get, and combine it with NaOH. This RNH part will give us an amide, RNH2, and this COO C2H5 part. This will get hydrolyzed to water and CO2 along with C2H5OH. So the key takeaways are the formation of this compound. The answers will be, in the first step, the product A that is formed is RNCO. In the second step, the product that is formed, the major product, is RNH2. Okay. So the correct option is option B. Okay. This is a question based on mechanism. Particularly, Wolff rearrangement is taking place in the first step, and in second step, it is NCO compound is formed, which is isocyanate. So an isocyanate will, when reacted with a base, it will give us an amine, primary amine. That was okay. Let's look at the next question. It is asking us, how can isopropylamine work? Okay. So if you look at the first step, CH3 whole twice, EHO. If you react it with H2OH, what is this reaction? With hydroxylamine, the carbonyl compound, it gives us an oxime as a product. The product will be double bond NOH, right? And after formation of this particular oxime, when you react it with LiAlH4, which is a strong reducing agent, you get NH2, which is isopropylamine. So the first option is correct. Let's look at the second option also. Whenever this kind of a compound, acetone, reacts with NH3, this will be not a feasible reaction because the reaction will be reversible. You get OH and NH2 on the same carbon. So this has a tendency to get reversed. Okay. So when this mechanism takes place, you get the original reactants once again. So the second step is not feasible. Okay. This will be in equilibrium with the reactants itself. So in the second step, if you want to reduce with H2Ni, that reduction will not take place. Okay. Moreover, H2Ni is not a strong reducing agent, so it will not be able to reduce it, this particular compound. In the third part, we have been given CH3C, CH3CHOH, CH3. And you react it with ammonia. Again, this alcohol is not a strong acid, and this ammonia is not a good enough nucleophile to attack on this carbon. This attack will not happen. So, if this kind of a reaction does take place, then we'll get here there will be no reaction. The second step, even if this is formed, we'll get an imine, and imines cannot be reduced by H2Ni. Okay. The structural form is A. Look at the next question. The structural form of a compound C6H11N that is optically active dissolves in dilute HCl and releases N2 with nitrous acid. So if the compound is releasing N2 with nitrous acid, that means it is a primary amine. Okay. So straight away we can reject option B and option D because they contain secondary amines. Right. Further, it dissolves in HCl. So nitrogen of the amine should have a nitrogen NH bond. Only then it will be dissolved in HCl. It can form a ammonium salt if there is NH bond. Okay. Further, it is optically active. So which compound is optically active? Compound A and compound C that are given option A and option C, they are optically active. And which compound has formula C6H11N? Compound A has C6H11N. Compound C has C8H11N. So the correct option is option A. Talk about the next question. Correct order of increasing basicity. Okay, so we have to compare the order of increasing basicity of aniline, ammonia, and ethylamine, diethylamine, and triethylamine. So we know the basicity of aniline. This will be least because nitrogen the lone pair of nitrogen will be associated with the benzene ring, so it will be in conjugation with the benzene ring. That's why it will not be able to get protonated that easily. That's why aniline will have the least basicity, followed by ammonia, followed by ethylamine, and here we have to remember the basicity order. So diethylamine is a stronger base than triethylamine. Due to hydrogen bonding, diethyl, uh, triethylamine will not be able to get protonated that easy. That's why C2H5 both thrice NH2. And lastly, we have C2H5 NH2 whole twice NH. Okay, so this will be the correct order of basicity, which is given in option number C. Right. The next question, we have reaction benzyl sulfonate fluoride PH SO2 Cl. It is reacting with ethylamine, and this reaction product A is formed. What will be that product? Now we'll get a sulfonamide when nitrogen reacts with PSO2Cl. NH2 will attack on sulfur and chlorine will depart. So lone pair of nitrogen attacking on sulfur and Cl will depart. Okay. So what will be the product? It will be PH SO2 NH ET. Okay. One of the H plus ions, one of the hydrogen atoms present on nitrogen will depart and we'll get a HCl as a byproduct. Okay. So this will be compound A. Now, if you apply NaOH, what will be the result? This hydrogen which is present on nitrogen, it is acidic. So what is the role of NaOH? NaOH will deprotonate this nitrogen. We get PH SO2 N minus ET. Okay. And further, when you react it with ETBr, there will be a SN2 reaction that takes place. So this negative charge will attack on ET, and the Br will depart. Okay. The final product that we'll get will be PH SO2 NET2, which is given in option B. Right? Let's look at the next question. How many primary amines are possible with the formula C4H11N? Primary amines that are possible are butanamine, butane 1 amine, butane 2 amine, two methyl propane 1 amine, and 2 methyl propane 2 amine. So there are 4 primary amines that are possible. Answer will be B. Let's look at question number 8. Here the following does not give ethylamine on reduction. We have methyl cyanide, CH3CN. If you reduce it, you get CH3, CH2, NH2. This will give ethylamine, no problem. Ethyl nitrile, we have CH3, CH2, CN. This is ethyl nitrile. When you reduce, you get CH3, CH2, CH2NH2. This is propylamine, not ethylamine. So this is not giving us the desired product. What about nitroethane? CH3, CH2, NO2. This is nitroethane. When you reduce it, you get the same product, CH3, CH2, NH2. And acetamide, CH3, CO, NH2. By using a strong reducing agent, you can convert it to CH3, CH2, NH2, right? So the number of carbons in the compound only is 3, then that compound will not be capable of giving an amine of 2 carbons, right? We need amine of 2 carbons, ethylamine. So ethyl nitrile is an incorrect option. So we have been asked which compound does not give ethylamine. So ethyl nitrile, option B will be correct. Okay. Let's look at the next question. We have organic compound C6H4N2O4 that is insoluble in both dilute HCl and base. Its dipole moment is 0. What do we mean by the 0 dipole moment? Even if there are polar bonds in the compound, the net dipole moment should cancel out. So which of these compounds have 0 dipole moment? The compound is given in option C, because there are two NO2 groups attached such that the dipole moment due to both NO2 groups will be equal and opposite to each other. So they will cancel out, right? So the net dipole moment, this will come out to be 0 in option C, which is para-dinitrobenzene. Okay. Let's look at the next question. So this one we have a reaction CH3NH2, which is reacting with excess of CH3Cl. What will happen? Here SN2 reaction will take place. CH3NH2, the good nucleophile, and when it reacts with CH3Cl, nitrogen lone pair will attack on carbon, CH3L will depart. Okay, and we write minus HCl. One of the hydrogen present on nitrogen will get combined with Cl to give HCl as a byproduct. So I am writing minus HCl to indicate that HCl has been removed. CH3 NH CH3. But again, this nitrogen still has lone pair. So again, it will react with, since the CH3Cl is given in excess amount, it will react with one more mole of CH3Cl. So what will happen? Lone pair of nitrogen will attack on CH3, and again, Cl will depart. Again, let me write minus HCl. The hydrogen present on nitrogen will get escaped with Cl minus, and the product that we get will be CH3 and CH3 whole thrice N, because there were 2 methyl already, and third methyl is getting attached now. Okay. Now, this nitrogen still has lone pair. What to do with this lone pair? It can still attack one more CH3Cl, but this time there is no HCl to escape. What will happen? It will combine with CH3Cl. This time we get a quaternary ammonium salt. We get CH3 whole 4n plus Cl minus. This is a quaternary ammonium salt, which is X. Okay. Now, what we are doing here, Ag2O in moist condition.